Yeah, warm greetings to everyone. Today we are going to discuss an exciting and rapidly growing field in rehabilitation engineering called virtual reality rehabilitation. So, virtual reality, commonly known as VR, is transforming healthcare by providing immersive and interactive environments for patients recovering from injuries, neurological disorders, and physical disabilities. Traditionally, rehabilitation involves repetitive exercises that often become monotonous. Virtual reality introduces gaming elements and realistic simulations that motivates patients to actively participate in therapy. In this presentation, we will explore how VR works, its application and advantages, limitations, and future developments in rehabilitation engineering. First, we are start with what is virtual reality. Virtual reality is a computer-generated three-dimensional environment that allows user to interact with virtual objects as if they were present in the real world. When a patient wears a VR headset, they become immersed in a virtual environment where they can perform various rehabilitation exercises. The main components of a VR system include VR headset. The headset displays virtual images and creates an immersive environment. Next, motion sensors. These sensors track body movement such as hand, arm, head and leg motions. Third one, controllers. Controllers allow patients to interact with the virtual objects. Fourth one, computer and software. The software generates the virtual environment and records patient performance. So, role in rehabilitation. VR is used in physical rehabilitation, cognitive rehabilitation, neurological rehabilitation, physiological therapy. This technology helps patients recover faster while making therapy more enjoyable. Before VR technology, rehabilitation mainly depended on conventional physiotherapy methods. However, traditional rehabilitation has several challenges. So, first we will see with challenges in conventional therapy. Patients often perform the same exercise repeatedly. Over time, these repetitive movements become boring and reduce motivation. Therapists may also find it difficult to monitor every movement accurately. Progress tracking is usually manual and may not provide detailed information. So these are the main challenges in conventional therapy. So why VR? VR solves many of these problems. It creates interactive environments where therapy feels like playing a game. For example, instead of repeatedly lifting an arm, a patient may be asked to catch virtual balls or pick virtual fruits. The system provides immediate feedback and motivates patients through score, rewards and achievements. As a result, patients participate more actively in the therapy session. So these are the main reason need for VR in rehabilitation. Next, we are going to see working principle of VR rehabilitation. Let us understand how a VR rehabilitation system works. First, the patient wears a VR headset. Motion sensor attached to the body continuously monitor movements. The software converts these movements into actions within the virtual environment. For example, if the patient moves their hand, the virtual hand also moves. The software compares the patient's movement with the desired movement pattern. It then analyzes performance and provides immediate feedback. This feedback may include accuracy, score, movement range, reaction time, exercise completion percentage. The rehabilitation process follows this sequence: patient, sensors, VR systems, analysis, feedback, recovery. This continuous feedback loop improves motor learning and accelerates recovery. So these are the working principle of VR based rehabilitation. Next, we are going to see types of VR systems. There are four main types of VR systems used in rehabilitation. First one, non-immersive VR. This uses a normal computer screen. Patients interact using a keyboard, mouse or motion sensors. Example, rehabilitation games on a monitor. Second one, semi-immersive VR. Large projection screens create a more realistic experience. Patients feel partially immersed. So third one, fully immersive VR. In this type, patients wear head-mounted displays such as Oculus Quest or HTC Vive. This provides the highest level of immersion. So fourth one, augmented reality. AR combines virtual objects with the real world. For example, virtual exercise instructions can appear in front of a patient while they remain in their actual environment. Popular devices include Oculus Quest, HTC Vive and PlayStation's VR are used for augmented reality. So these are the four main types of VR based systems. Next we are going to see applications in rehabilitation. So VR is used in many rehabilitation areas. Physical rehabilitation. First one we are going to see physical rehabilitation. Patients recovering from injuries perform exercises in a virtual environments. Application include stroke recovery, balance training, gait training, upper limb rehabilitation. So next one, neurological rehabilitation. VR helps patients with Parkinson's disease, spinal cord injuries. So next one, cognitive rehabilitation. VR improves mental functions such as memory, attention, concentration, problem solving ability. The immersive nature of VR increases patients' participation and treatment effectiveness. So next we are going to see VR for stroke rehabilitation. Stroke is one of the major causes of disability worldwide. After a stroke, patients often experience weakness in their arms and legs. VR-based therapy encourages patients to repeatedly perform movements in an engaging manner. Benefits: improved motor function, better hand-eye coordination, increased engagement, faster recovery. So example activities for stroke rehabilitation: patients may grab virtual objects, catch virtual balls, perform arm reaching exercises. So next we are going to see VR for gait and balance training. Many patients struggle with walking and balance after neurological injuries. VR provides safe environments for gait training. Examples include virtual obstacle crossing, stair climbing simulation, walking through virtual pathways. These exercises improve walking speed, balance, postural stability and reduce the risk of falls. So next we are going to discuss comparison between conventional therapy and VR rehabilitation. Let us compare conventional rehabilitation with VR rehabilitation. In traditional therapy, patient's motivation is moderate because exercises are repetitive. VR therapy is highly engaging because it uses interactive environment and gaming concepts. Progress tracking in traditional method is often manual. VR automatically records movement data and performance statistics. Traditional rehabilitation generally requires patient to visit hospitals. VR rehabilitation can even be performed remotely at home through tele-rehabilitation systems. Therefore, VR provides better customization, motivation and data collection capabilities. Next, we are going to discuss advantages and limitations of VR based rehabilitation therapy. So advantages: VR rehabilitation offers several benefits. First, it increases patient motivation through gamification. Second, it provides real-time feedback. Third, it allows therapists to monitor performance accurately. Fourth, exercises can be personalized according to patient needs. Fifth, remote rehabilitation becomes possible. So despite of these benefits, there are some challenges. The equipment can be expensive. Some users may experience motion sickness. Technical issues such as tracking errors may affect performance. Proper training is required for both therapists and patients. In rural areas, access to advanced VR systems may be limited. So next we are going to discuss recent advances and future scope. The field of VR rehabilitation is advancing rapidly. AI based rehabilitation, artificial intelligence analyzes patient performance and automatically adjusts exercise difficulty. Haptic feedback, haptic systems provides touch sensations. For example, when a patient touches a virtual object, they feel vibration or pressure. Third one, tele-rehabilitation. Patients can perform therapy at home while therapists monitor progress remotely. So another one, wearable sensors. Advanced sensors improve movement tracking accuracy. So now we are going to discuss future scope. Future system may integrate artificial intelligence, brain-computer interfaces, rehabilitation robots, metaverse healthcare, cloud-based therapy platforms. These innovations will make rehabilitation more accessible and effective. Finally, we are going to see conclusion. It provides immersive and engaging therapy experiences that improve patient motivation and treatment outcomes. VR enables personalized rehabilitation, real-time monitoring, and remote healthcare delivery. Although challenges such as cost and technical limitations still exist, continuous advancement in AI, wearable sensors, and robotics are making VR-based rehabilitation more effective and affordable. In the future, virtual reality is expected to become a standard component of rehabilitation programs worldwide. So thank you for your attention. If you found this video useful, please like. For more videos on rehabilitation engineering, biomedical engineering, medical devices and healthcare technology. Thank you for watching.